Hello, I'm Charlie Smith. I'm the National Recover Manager for McElroy Metal, and I want to welcome you to my barn here in beautiful Round Top, Texas, where we're going to be shooting a series of videos on metal retrofit, or how to use metal in retrofit application. And so this video and a couple of more after this that are going to be in a series are going to concentrate on putting a new metal roof over the top of an existing metal building that is where the roof is installed on open purlins. So, this is a big area. There's billions of square feet of these types of buildings that are screaming for new roofs, and so that's what we're going to cover. We're going to talk in this first video. We're going to talk about the generalities of doing that type of work. We'll start with why do a recover. The main reason to me for doing a recover is the interruption to the occupant. Tearing a roof off of a metal building and leaving it wide open up there is a tremendous disruption to everybody that's in there. You're talking about people that have to be moved. You're talking about inventory that has to be moved. You're talking about processes that have to get shut down. And so when you do a recover, you eliminate most of that interruption. So that's a great reason, because the business can continue to function as normal inside while you're putting the new roof on. Another thing is the energy code. We have a new energy code that says that if you remove and replace an existing roof, that you're going to have to bring the new roof up to the current energy codes. The current energy codes can be quite onerous, and I don't think that every building in the country needs to have 9 or 10 inches of insulation in it, and I guarantee a lot of owners don't believe that either. So one of the exceptions in the energy code is if you do a recover, you don't have to bring the building up to the current energy code. So that leaves the amount of insulation that you put into the new roof, or if you add insulation at all, up to the owner and the contractor. They get to make that decision, not somebody else. And I like that. Structural enhancement is a big part of doing recover. There's a lot of buildings that are out there that are not, not as good as they should be, right? And whether it was originally designed that way, or whether it was not installed correctly, or if there's been a lot of modifications to the building since then the idea of enhancing the structure while you're putting a new roof on it is a beautiful thing. And so there's a number of ways to do that. And this is a big part of doing recover with metal, is that you have an opportunity to increase the load carrying capacity of the purlins while you're doing it. And there are ways to do it, and we're going to get into those more detail shortly. Trash is another big deal. One of the things that I like about doing recover is that, I personally diverted millions of cubic yards of trash from going into landfills. And I think that's a great thing. And so the more of that stuff that we do, the more roofs that we encapsulate inside underneath an existing roof, then that's less trash that's going to be put into a landfill and taking up space. So I think that's a great thing. Why use metal? Why not use single ply? Well, best reason is metal lasts way longer than anything else. They've got Galvalume projected to go out like 50 or 60 years right now. And so when you put that into cost of ownership, then metal is by far the lowest cost option. There's no doubt, no dispute. Once you put the numbers to it, there's nothing less expensive to put on than metal. Initially, there's other ways to do it that cost less money, but they don't last very long. So metal has got the enormous lifespan. Okay. The other thing about metal is that this is what the building is designed for. You got a metal building, it's designed for a metal roof. It is designed for the water to be channelized and run up and down, run off the building in a straight line. If you put a smooth surface roof on top of a metal building, then you've taken that channelization away, and the original design intent of the building has been changed, and design intent of the structure. The IBC allows for a different level of deflection in the purlins of a metal building than they do on standard construction, where you use bar joists in a steel deck. And the reason that they allow for more deflection on a metal building purlins is because of the fact that the water is channelized, and they know they're going to get equal loading across there. Then once the water's not channelized, and the water's free to flow to the lowest point as it's going off the roof, which is going to be mid-span of the purlins, which, you know, generally is 99.9% is not a big deal, but there have been buildings that have collapsed as a result of having a single ply roof put on them because of the way the water's channelized. And that's happened, and so people don't really like to talk about it, but it's a real deal. And there's been a number of papers out there put out there on the subject. So before you decide to throw a single ply on your building, you might consider looking up on some of this information. There are three basic types of metal roofs that you're going to find on a metal building. And I've got two of them I'm showing here, and then with the third one we can extrapolate, all right? But the most common thing you're going to see on a metal building is one of these things. It's called an R panel. This is a 12-inch on center rib exposed fastener panel. That means it's screwed right through the panel directly to the purlin. Okay, these panels are 3 feet wide, come 24, 26 gauge. There are all kind of versions of R panels, but basically this is very, very common, all right? The main thing that all these panels have in common is that they are part of the structure. The building was designed to have this panel on it, and this panel is holding the building square. It's like a sheet of plywood. So you can't just take one of these panels off and then put a free-floating standing seam on, because if you do, you're liable to have a real big problem. So people that say, I want this off and I want something else on, that's great, but if you do that, you're going to have to make some alterations to the structure to make that happen. So that's why I always try to leave one of these R panels or screw down panels in place, because I know it's part of the structure. I know it's doing the job. I don't care if it's all rusty and full of holes. It's still doing its job. And so I always try to recover one of these. The other type of roof is going to be a standing seam. And there's two versions of a standing seam that you're going to encounter out there. And this is real important if you're going to talk about recover, to understand which one that you've got out there. This is a high floating standing seam. It's a high floating standing seam because there's a 1-inch space between the bottom of the roof panel and the top of the purlin. And there happens to be a 1-inch thermal space or a styrofoam block in here that separates the two, okay? This is real important that you figure this out. The other type is a low floating system. So a low floating system is going to have a clip that holds it lower, and it's going to have like a 3/8 inch space here, or maybe 0 space. These, with the low floating systems, can be retrofitted in a very similar fashion as these types of panels. The high floating systems have their own systems that go with them, and they cost more money. And so if I was looking at a job, this is the very first thing that I want to find out is what do I have existing? Is it a high floating system or a low floating system? And so the best way to figure it out that I've found is just to drill a damn hole right through the panel right there when you're on top of it, and bounce the drill bit off the purlin and measure how far you go in. It's either going to be 0, it's going to be 3/8, it's going to be 1 inch, it's going to be 1.5 inches, or maybe even 1 5/8, okay? So you need to know what that is so that you can understand how you're going to retrofit this thing, because you retrofit it completely different, something like this to something like that. That's a big deal. Figure it out before you bid the job, or you're liable to be in trouble. Okay. Questions about weight are probably the most common things that I get concerning metal retrofit or retrofitting existing metal building. And it's a valid concern, all right? Let's talk about what does the code say, because there is a code that deals with this in the International Existing Building Code. It's section 707. And in simple terms, it says that if you're going to retrofit an existing roof with a new roof, that the structure below must meet the current IBC loads. So a lot of the older buildings are not going to meet the current IBC codes, and you would have to rebuild the whole building in order to make that happen, right? But there's a couple of exceptions to the code that are, first, that the new roof does not increase the load on the existing structure by more than 5%. That's one. And then the second is that the new roof going over a single layer of existing roof does not weigh more than 3 pounds per square foot. Okay, that's what the code says. You get 3 pounds. Now, that's not to say that you should not have an engineer come in and look at the building. And I'm talking about a qualified engineer that works with metal buildings all the time. Because to me, those are the guys that really understand what to do and can figure out how to fix the problem if there is a problem. Okay? But qualified engineer that's really got a lot of experience with metal buildings comes in and looks at the structure to make sure that it was built the way it was supposed to be built, that it hadn't been modified in a way that it shouldn't be modified, that it doesn't have excessive weight hanging from the rafters, that the purlin laps are going to be okay, that the right gauge purlin was used, and all the things that are going to be important, because you just can't go in there and make the assumption that it's all good, okay? But I would definitely focus on, I've done hundreds and hundreds of these jobs. I use a guy in Houston, Force Engineering, and I don't know how many site-specific tests that we've done because of weird stuff that we run into. So I think somebody that has that big, broad experience is going to be real important for you, okay? Structural enhancement. So we talked about this is a big opportunity within the business. So if somebody looks at the buildings and determines that the purlin's laps are short, or that the gauge was incorrect, or in general it's just not up to snuff, or you get up there and you walk around and it feels like you're on a trampoline, I mean, that's a pretty good indicator that things are pretty flimsy up there. And so there's ways to enhance the structure, and the way that you do it is using a notched purlin, okay? This is a roof hugger. This is a Model C roof hugger that's designed for an R panel. You can see it's a Z-shaped purlin, 16 gauge. It's got it's unequal flange. It's got a notch cut out every 12 inches. Got a notch cut out every 12 inches to go over the ribs of the existing panel, and it's got holes punched for the fasteners to go through. So this thing goes right over the existing panel, right over the ribs, sits right on top of the purlin, and then you're going to attach through these holes into the purlin. And basically what you're doing is increasing the height of the existing purlin, because you've got a rigid attachment now between the new purlin and the old purlin. And I guarantee you, it will make the existing purlin stronger, okay? And the amount of strength that it adds depends on the height of this part, the gauge of this part, and the height of this, the amount of beef you got over the top of this cutout. Those three things are going to make a consideration on how much you can enhance the structure. Now, we've had some jobs where we needed something a little bit beefier, and so this is something that we've made. This is we can make this part 4 inches to 12 inches. And so what you see here, this is a 4-inch retrofit purlin that's notched. It's a symmetrical part, and it's notched out to fit over the ribs of this panel, but now you've got quite a bit of beef over the top here. And so, and then these parts were actually manufactured in full length as the original purlins, so that they had the same lap and everything. So they were 27 or 28 feet long, and they lapped over the top of the existing lap like normal. So we're talking about some serious structural enhancement can be done to an existing building while you're retrofitting it from the top. And so now we're talking about fixing your roof problems and fixing your structural problems at the same time. Pretty sweet deal. You have to be careful about a couple of things. Structural enhancement will work on top of an R panel, right? Because we got this rigid connection here. It will work on a low floating standing seam because you're going to be able to smash this panel flat down on the purlin. It will give you enhancement as well. But you are not going to get any enhancement out of a high floating system. So don't have that expectation that you're going to get enhancement if your existing panel is floating an inch above the purlins, because you're not getting any, okay? Those are real important things to understand. Wind uplift. You got a building, you want to put a new roof on it, the new roof has got to meet the wind uplift, the current wind uplift codes. And so this is where if you've got an existing building that's got purlins at 5 foot on center everywhere, then your new roof panel needs to meet the wind loads, the current wind loads at 5 foot on center on the whole structure, and including the corners, where the wind pressure is probably going to be greater than what most panels will achieve. And so most of the time when you do a retrofit, you're going to have to add some framing or do something creative in order to be able to meet the current wind loads, okay? So one way is to add purlins from underneath between the existing purlins. And so this may end up happening in the edge zone or just the corners or the corners in the edge zone. Adding purlins from underneath sometimes can be easy, sometimes it's impossible. So every job's different, all right? The other way to do it is that you can do a grid on top of the roof. The guys at Roof Hugger have a grid system where they run half sections that go up and attach to the existing purlins, and then you can take roof huggers and go across mid-span of the existing purlins. That works really good. You can also do a grid with purlins where you've got purlins that run up and attach to the existing purlins, and then you can go across the top of those with hat sections. Those all work. They add weight and add a tremendous expense. I can tell you that right now, okay? Me personally, I like using continuous clips. So instead of individual clips on my new roof system, on my new roof panel, I use continuous clips. And continuous clips are going to span multiple purlins, and they're going to have a significant increase, or they're going to significantly increase your new roof panel's ability to meet the wind uplift. So my objective is always stay at 5 foot on center on the framing. That way you're not increasing the cost, you're not increasing the wind load. I mean, you're not increasing the interruption to the occupant and the cost and the dead load, but you are dramatically increasing the wind uplift capacity of the roof system. And so we're going to get into different roof systems in another video after this, but this is how I get through all this stuff. And so I've maybe done 2 jobs out of, I don't know how many thousand, where we ended up having to add framing because the wind pressures were just too high. And we've done a lot of really high wind load jobs. So that's going to be real important, okay? So I've got some upcoming videos I'm going to do that are going to come right after this. The first one is going to be what panels can you use for doing recover. The second one is going to be like 5 ways to recover an R panel. And then it's going to be 3 ways to recover a low floating standing seam, and then a couple of different ways to recover a high floating standing seam. And then we'll move on to something else. But that should pretty much cover the whole metal building recover routine. I appreciate you watching. You got any questions, you can email me, csmith@archmetalroof.com. That's ARCH metalroof.com. I'll answer any questions anytime. Thank you so much.